Hey everyone, I'm Sriharsha, and
I'm Parth.
okay, today we are going to talk about the internals of Apache Kafka security that we pushed as part of the 0.9 release. So before getting into why we added, what's the need for it, Kafka is increasingly becoming the central data bus for everything that's coming from outside sources, getting to Hadoop or your streaming needs. So you have external agents that are coming, talking to Kafka, and also you have other external agents that are reading the data from Kafka. So especially when there are some users who are using Node.js directly pushing data from their websites onto the Kafka itself. So you need wire encryption, and you need role-based authentication as well. So that is one of the paramount reasons that we added a security in Kafka. And if you go look at Kafka mailing list, there has always been discussions about Kafka security to be added over the years. And as part of 0.9, we made it happen. So we recognized the necessity of that security feature, and we added a SSL support. So you have Java API that can do non-blocking SSL, and we added Ssl. Ssl with Kerberos can do a role-based authentication, user authentication, and then you can add Authorizer on top of that. So by Authorizer, you can say which topic from which host can be accessed, and you can revoke and add access control to this particular topic. So before I get into more in terms of the security stuff that we did, I'm going to give a brief primer about the networking stuff that goes on in Kafka server. So in Kafka server, there is a socket server. It listens on a port. So what you interact with Kafka is you send a response. So you send a request, you get a response from a client. So in network layer, it's a non-blocking network layer. So it's not traditional that once you open a socket connection, that the connection is kept active for the length of the duration. So what happens is we have an acceptor thread that takes the incoming connection. It creates a socket channel and hands it over to multiple processors. So as the clients are sending data, there's a selector loop that goes and invokes the ready sockets and reads the data and gives it to processor. Processor and goes back and gives it to Kafka APIs, where you have metadata request, create topic, produce request, and all the requests that will happen, and send it back to the same socket channel once the response is ready. So this is a simple select call that goes in. So you have, if a client is idle, the socket channel for the client is not being invoked. Whenever there is an input data that's coming in, it gets invoked. Whenever there is response is ready, it gets invoked. So that's how the Kafka can scale to hundreds and thousands of client connections simultaneously. So if you look at, it's similar to Netty, what Netty does. So what we do is independent of that. So we have an acceptor and processor model there. So that's a brief introduction of how the networking happens in Kafka. So when we started looking at adding SSL support and Ssl support, and we wanted to make sure there is no user level API changes. That is, as a user of Kafka, as a client of Kafka, you're not supposed to worry about any changes that's happening inside the stack that we took care of. And in Kafka, pretty much all the requests and response are length encoded. That is, you're saying that I'm going to send this request, and this request is of this much size. And on the Kafka side, we read the size, and we read that many bytes. That's when the request is complete. And then we go and process that particular request. Similarly, the response is written in the same way, that it is length encoded. So we want to retain that. And client must always authenticate before they can proceed sending any request to Kafka. So these are the minimum requirements that we took that we want to have that. And the last one is the Kafka channel. So right now, if you look at before adding security, what we have is a socket channel. It's a simple Java socket channel. You open a socket channel, you connect to the other port, you started sending the bytes and out, read the bytes. So what we did is have a trying to find the image. Yeah. So what we have is the Kafka channel here. It is abstracted away a lot of the socket channel implications that goes in. So we have a transport layer. So what transport layer does is it only takes care of writing the bytes onto network. So all your networking details are went into transport layer. So you see plain text transport layer that is pretty much similar to what we have before, a simple non-secure port. So the behavior will be same as before, like in 08 Kafka. You open a port, you start transferring Kafka application protocols. That's what transport layer does. And the transport layer, we have plain text as well as SSL. I'll go much more deep in details there. And then we have Authenticator. So Authenticator on top of transport layer, lives on transport layer. So once the connection is established from the transport layer, Authenticator starts its process, saying that, for example, in Ssl case, you need a connection to be established, then you start handshaking with the server. So Authenticator is pluggable. That's where the application level authentication takes place. So we went ahead and wrote the SSL transport layer. Again, SSL. So as part of the SSL transport layer, again, we need to take care of, it's not as simple as like open SSL socket channel, connect to the endpoint, and just start internal handshake. We have to do the handshake ourselves in the networking layer in a non-blocking fashion. So whenever you open a producer client or a consumer client, consumer API using Java API, it establishes a connection first, socket channel, before sending any, let's say, topic metadata request or any other Kafka request. Client will come up with its own key store. Server is already listening on a port with its own key store as well as trust store. Client has an optional key store option. That is, if you want to have a mutual authentication between client and server, you need a key store. If you don't, you can just need a trust store. That is, the trust store will contain the server certificate saying that you trust the Kafka broker there. So the client will come up with a trust store. As soon as it comes up, it makes a connection to the broker. It starts sending its certificates, and server gets a certificate, and the mutual authentication takes place where server looks up its trust store. Do I trust this client that is connecting to me? Once the trust is established, we call that handshake is complete. From then on, the producer or a consumer is free to send any request from then on. So whenever they send a request, SSL transport layer takes care of wrapping that data into encrypted format and sends the data into server. Server unwraps it, understands what's inside in it, and makes that as a Kafka application protocol, sends it to other layers downstream. So basically, this transport layer is only happening when the bytes are being flown between the network layer. So it's pretty much hidden from, everything is hidden from the client. So all they need to do is configure their trust store and the key store and specify what the protocol they're going to speak. And internally, we take care of all the handshake and connection reestablishment in case there's a connection broken, and how the bytes that are flowing through are getting encrypted. So one of the complications when we are building this is the interesting thing with Kafka application protocol, length encoded protocols is, let's say if you're sending a 2 MB packet and you're only able to send 1 MB, you still need to finish that in one go. When you do a socket channel write, you're only able to send 1 MB of data. You still need to keep track of what's left in the request before proceeding further from the client side. So that is possible with a non-encrypted channel. That is, socket channel will return whatever the data it's written, whatever the length that's been written to this channel. Whereas in SSL, we have to do all this rework. Because of encrypted channel, we will write more than what it actually says at the source, because the packets will be bigger than that. So we have to keep track of that. So again, the SSL transport layer will take care of keeping track of it and sending the bytes and only moving forward when the request is complete. So once the socket channel is established, there is an identity that is established for the client. By default, the identity will be the host name of the connection that's coming from. In some cases, in SSL, especially in SSL cases, right, you want to add some more data into your X509 certificate and read that certificate and try to establish the identity. Just having a host name wouldn't give much details about which application is connecting. There might be multiple consumers in the same host. You want to kind of give different access controls to different connections. So just having a host name won't help here. So what we have a principal builder interface where you can write your own custom principal builder, and we will give you the X509 certificate. You can look into that and establish your own identity. And from then on, Authorizer will take care of how to impose the ACLs on them. So in SSL format, so this is how it looks like. So the listeners, the first config is, if you look at previous versions of Kafka, you will be probably configuring via host name and port. That thing is changed to listeners now. The first part, SSL, is the the protocol that the broker going to listen on, and the next name is the host name and the port. The good thing with the listeners is you can add multiple ports. That is, you can have an SSL, Ssl, and a plain text at the same time, especially useful if you are upgrading from a existing cluster and going to a secure cluster. You want to transfer your existing non-secure clients to the secure clients. You can have a plain text protocol, keep them running. While the brokers are coming up, you can switch the port on the client side and start connecting to a secure port. So that's pretty much what they need to do. So as a users, you don't need to do much more than configuring these set of options. On the client side, again, similar set of options. Instead of listeners, you're going to configure security.protocol. That is, you're talking which protocol you're going to choose from the client side. Once you specify that, client will initialize this SSL engine and start communicating to the broker at that port. So next, we jump into the Ssl and Kerberos part. So Ssl allows you to kind of gives you a pluggable flexibility to actually not just talk to Kerberos, but also use LDAP to log in and start exchanging that as your your tokens in between to establish the handshake. For example, right now we support Kerberos, and it's easy to add another module, kind of LDAP. Just in your JAS config file, you can mention that you're going to start authenticating with LDAP. So the client and the Kafka broker will come up and log in with that credentials. And when the client starts connecting to the server, they exchange those tokens and establish the identity of the clients and start authorizing the request from then on. So this is how the JAS config file look like. So it will, right now, in the first line of that is KRB file login module. That tells that the client or any broker that they are using Kerberos in this case, and it gives you all the key tab and principal. So as soon as the broker comes up, it logs in with that particular key tab, and client also logs in with its key tab. So they mutually authenticate each other. And the other side of the session, on the broker side, the client will have the identity of the Kafka client section here. So they will be known as, I am the client coming from this host. So the authorizer will have the access to that principal, and you can set access control based on that principal. So this is simple handshake, how that goes. So as soon as the client comes up, broker is already listening on a port. They start connection, and broker returns a mechanism list. Mechanism is like, do you want to use Kerberos, you want to use MD5, LDAP, whatnot. Client select whichever mechanism they want and start sending the challenge and response mechanism. And once everything looks good, the client is authenticated and connection is established. And again, the same thing goes on, that is sending the application level protocols. So that's, in a nutshell, is the network side of the point. So we have links here. You can go look at how to deploy Ssl in production cluster as well as Ssl. We have Vagrant setups as well. So if you want to kick off a simple test, you can do so using that. So that's pretty much about networking part of it. Now we go into authorization.
Thanks. So hi, everyone. So what Harsha covered is how do you establish identity of a client. So once the server knows that you are who you say you are, the question comes, what can you do on the cluster? And that's where the authorization comes into play. There are three things the authorizer basically allows you to do right now in the current implementation. One, it controls who can do what. Second, it's a pluggable module, meaning by default, we give you a very simple authorizer which is using ACLs, the access control list that is controlled by Kafka, but you can plug in your own authorization. So if you are an AWS customer, you want to write something which will work with AWS Identity and Access Management Service, you can write your own authorizer, plug it in with Kafka, and it will work through that. We are going to cover the ACLs. So if you look at what the Kafka ACLs are right now, it consists of 5 parts. The first part is a principal, which is the identity. In Linux case, let's say it's a user. So the principal is Alice in this case, in our example. There is a permission which has 2 types, either allow or deny, whether you are allowed to do an operation or to deny an operation to you. The operations is a list of bunch of operations that we'll go over. The resources, right now there are 3 resource types, a topic, a Kafka topic, a Kafka cluster, and then finally there is the consumer groups which are used by different consumers to consume different bytes from the Kafka topic partitions. And then finally there is host, and this host part basically allows you to say only allow this user to access from these hosts. That way you're basically kind of doing an IP table at a much higher granularity. The principal, which is the first part, it's represented as a principal type colon name. Right now, Kafka only supports user, but because this is an extendable framework, you could plug in any other type that you like. We have an open PR for group support, which is kind of open since a long time. But once we have group support, then you can also specify Unix groups where a group will have access to certain topics. There is a wildcard user, so if you have a topic that you want to keep it open, or let's say you are running Kafka in a mode where you have a secure channel and an unsecure channel, then you can say this topic can be accessed from any user, and that way you can just specify a star there. The operations right now, there's a list here. We had two options. One, either to have a subset of operations like that and then map them to the existing Kafka APIs, which are longer than the list here, or create an operation per API name. The problem with going with the second option is the fact that anytime you add a new operation, now you have to go back and add new ACLs, otherwise it's not going to work. So instead, we were able to convince the community that it's better to just move off and classify things. As long as you are adding a new API or modifying an API which still fits into one of these classifications, you don't have to change your ACLs. Things will just work with the existing ACLs. The resource is also just like principal. It has a type and a name. Right now, the type is a topic, a cluster, or a consumer group. I think moving forward with Kafka Streams, K-tables, K-connect, as we add support for those, we may add more types there. There is also, again, wildcard support, so you can just say this user can access all topics. The permission, so this is where I think that this is one of the controversial ones. We right now have allow and deny. By default, if you do not specify an ACL to say this user has access to this topic, they are denied. So by default, if you don't have an ACL which says you are allowed, you are denied. Then the question is, why do you have deny? And the primary reason was we had use cases from certain customers who said, what we really want to say is, I want to allow everybody in finance department to have access, but these two interns. Nothing against them, but that's just how they wanted it, right? And now your options again are list everyone in finance department, give them access, and then as new employees come, keep giving them access, but make sure those two guys, they don't have access. Or you give a negation operator. So deny just works as a negation right now. The host. So again, why do you give this granularity? Generally, when you give access to a user, you want them to have access across the cluster. The problem with that is, one, if you are one of those guys who doesn't like Kerberos, like most of us, then you have an unsecure cluster, and in that case, you still want to have some control. You have some compliance requirement which says at least control it at IP table level. Now you go and modify your IP tables across all your hosts. Anytime a new broker comes up, make sure the same IP table settings are applied to it. Or from Kafka, we give you a way to define IP table-like rules, and that way, even in an unsecure mode, you have some security. At the same time, in secure mode, of course, you can also enable it, but there are tighter granularities already provided, so you probably don't need it in a secure mode. Star as wildcard with all of the things. There are 3 or 4 configurations right now. An authorizer class, because it's pluggable. Right now, by default, it will use simple ACL authorizer, which is a Zookeeper-backed ACL management tool. Then there is a super user, and this is primarily used for Kafka's internal communication. So your Kafka servers, when they come up, you are specifying that this server will come up as this user, which is generally Kafka broker at your realm. You want Kafka brokers to have super user access, so they can access any topic during replication and all the other things that Kafka does internally. And you don't want to have to define ACLs for those. So super users comes handy in that. The authorizer properties, and there are 2 properties that you can generally specify, one of which is this, the default behavior for resource with no ACL, again a controversial one. By default, as I said, if you don't have an ACL, we just deny you. The problem was when you are migrating from an unsecure cluster to secure cluster, what do? Do you first define your ACLs even without having a secure cluster and then do the migration? Or we give you an option to say, right now, allow everyone, even if they don't have an ACL, and when we have ACLs defined, we're going to redeploy the configuration, and you can bounce the cluster one more time. So those are the current simple ACL authorizer configuration that you have access to. Simple ACL authorizer, I think I already kind of covered it. It stores all of its ACLs in Zookeeper. Don't worry that Zookeeper is not going to be able to handle the load because it has its own cache. It's not really hitting Zookeeper with a lot of load. Only when you add an ACL, it writes something into ACL into Zookeeper, and at that point, the ACL authorizer on all Kafka brokers kind of syncs their cache, and they have the updated ACLs. It also has an audit log, but it's at a very smaller level. Like it actually, if you enable it, I think you will see a relatively higher performance bottleneck because it's logging every single operation that comes in and says this user was authorized, this user was not authorized. This is kind of the flow of how the simple ACL authorizer works. During broker's initialization, broker calls authorizer's init method or the configure method, which reads all the ACLs from Zookeeper and initializes its cache. Anytime a request comes up at that time, because Kafka is supposed to be a high throughput, low latency system, we don't want to hit Zookeeper on every request just to validate something. So we look at our cache as long as the ACL, either there is an ACL match, meaning you have an allow ACL, or if you are one of the super users, you are granted the access. If you somehow get into a deny ACL list, then you are denied. It doesn't matter if you have an allow ACL or not. If you match a deny ACL, you are always denied. There is a CLI support, so there is a command line utility. You don't have to use Java APIs every time you want to add ACL. You can run the command line utilities just like your Kafka topics. There is a Kafka ACL.sh, and you can add, remove, list ACL. There is also a convenience option to say, add this user as a producer or add this user as a consumer, and that will take care of actually allowing all ACLs that are required for a user to be either producing or consuming. There is also Apache, because we have the pluggable authorization, there is Apache Ranger, which many of you guys might be using, or Apache Sentry, which is another authorization mechanism in Apache world. Both of them have a plugin for Kafka, and they come up with this nice UI. If you don't like CLIs, you can go there, click some buttons, and that will define the same Kafka ACLs that we just saw. It also provides nice auditing. Ranger at least does, I don't know about Sentry. And they batch these auditing operations, so your performance bottleneck won't be that high. And finally, this is like an ACL management audit UI that they have. So after all this, what we covered so far is we have SSL encryption, so your wire protocol, all the data going over the wire is secured. You now have Ssl or Kerberos support, so everyone who comes in, they have to prove their identity. And finally, we have authorization, so only people that you want to access something can access it. So we have tight security, right? Like that should cover it. But with everything that we just discussed, the security in Kafka world looks like that. Because this is basically Kafka's metadata store. It's an unsecured Zookeeper. Right now, Kafka stores ACLs in simple ACL authorizer in Zookeeper. Kafka stores its metadata in Zookeeper. When you create a Kafka topic, there is actually no API. You have to run a command line utility which doesn't really talk to any Kafka brokers, just inserts a row in Zookeeper. So if you don't have Zookeeper secured, everything else that we just covered is not really important. So we had to secure Zookeeper. Because Zookeeper's Kafka's metadata store, Zookeeper needed its own security mechanism. Zookeeper as a separate product itself has its own security module. You have options to either use Ssl, just like Kerberos, or just like Kafka Kerberos setup that we covered, or you have a digest MD5 option where you don't use any key tabs. You just create a digest MD5, plug it in with username and password, and that's what Zookeeper will use to authenticate. So in this case, now what is happening is when you start your Kafka broker, at that time in the JAS file that was shown to you before, you will actually add another JAS which looks something like this. So in this case, what we are saying is Kafka server is connecting to Zookeeper as a client, and it's going to use this key tab, and the service it's trying to connect is running as Zookeeper user. Now, is there a way to go back? Yeah, thank you. So now the ACL on what this is allowing you to do by default, it will create an ACL on all your Zookeeper nodes. So every Zookeeper node for Kafka metadata now has a user : what it can do. By default, what it does is it allows all permissions to the Kafka user, the user that your Kafka server is running as. So your Kafka brokers can actually do everything. The only problem with this setup, as I mentioned earlier, is Kafka doesn't really have an API to create a topic or to delete a topic. So when you are now using those Kafka topic.sh scripts to create, they will fail unless they are run with the JAS config of the Kafka server-side broker. This is something being addressed right now. There is a KIP called KIP4, which has been going on since almost 1.5 years now. But that's how things move in Kafka world. So hopefully it'll be done sometime this year, and then we'll not have that problem. There is a Zookeeper migration script, again, to make sure that you have a very smooth transition when you migrate from an unsecure Zookeeper to a secure Zookeeper, where some brokers don't yet have Zookeeper key tabs installed, and some nodes do. So you can use one of these flavors, and this work, we proposed the original design, but the work was done by Flavio, so credits to him. What are the future things that we are going to actually do? KIP4, as I mentioned, going on. The group support, so that you don't have to actually individually define ACL for every user that you want to give access to. The pluggable auditor, as I said, right now the auditor, there is no auditor. It's like a log.debug. We want to add a support so that when an operation is authorized or denied, we can give you a batch, just like Ranger, and you don't have to depend on one more thing. There is delegation tokens. That's another KIP, and it's being discussed right now. I don't know if people are aware of Hadoop delegation tokens, but basically, if you think about Storm or any other streaming engine, so Kafka itself is just a storage engine. You'll probably need some streaming or some processing engine running on top of it. These processing engines, generally, when they want to access Kafka, what they will have to do is they'll have to distribute a key tab across their entire cluster. So if you're running a Storm cluster with 200 workers, all 200 workers will now have to have a key tab that they can access Kafka cluster with, which is painful and at the same time creates an operational overhead. If you think about what's going to happen when I want to add some new nodes, and what if I forget to add key tabs on those nodes. So delegation token is a mechanism by which what you are doing is you assign one master, which most applications do. Like in Storm's case, it's Nimbus. In Spark case, there is an app master. So most applications have a master, and that master is the only one which needs to have a key tab. He authenticates, or it authenticates with the Kafka broker and says, give me a token that I can distribute to other people, other workers. Once it has that token, it is responsibility of that master to distribute it to its workers. And once the workers have access to it, they can present those tokens to the broker when they are doing communication with the broker. And broker will identify as the same identity that was established by the original master. So this reduces one load on the Kerberos KDC server, which gets overloaded with huge clusters. And then at the same time, the operational management issue becomes much. It's still a problem because in certain cases, but it becomes much less of an overhead at that point because you are just distributing the key tab to certain nodes rather than every single node on your cluster. The final thing is impersonation. This is, as the name suggests, a way so Kafka, at least Confluent, has this Kafka REST API using which you can produce or consume messages using the REST version. The problem is if your Kafka cluster is now secure, either you have to add the REST as a super user, and then anybody who has access to REST becomes a super user because he can produce or consume from any topic. On the other hand, what you really want to do is, if a user makes a request to the REST API, you want the REST to make a call to Kafka on behalf of the user and say, user one wants to write to this topic, is he allowed or not? So impersonation is something that will help in that case because it will basically solve that problem by making sure that the REST API can impersonate another user. And this is not even in discussion. That's something that we still have to propose and see if it gets accepted in the community. I think this covers what we wanted to discuss today. You now basically with 0.9, Kafka version 0.9, you can configure your Kafka brokers to have SSL wire encryption. You can have Ssl for authentication. Right now, Kerberos is the only one supported, but you can plug in your own authentication model, whatever you like. There is pluggable authorization with a default implementation which stores ACL and Zookeeper, and then the secure Zookeeper to make sure that you actually are secure, not following some compliance which doesn't really follow the compliance. So with that, we'll open the floor for question and answers. Thank you.
Thanks. Sorry.
You can go ahead first.
Why do you store ACLs on Zookeeper but not in a special Kafka token? It seems to me like the same story with offsets. Initially, offsets have been stored in Zookeeper and then migrated to a special Kafka token.
Right. So I think the ACL themselves, unlike offsets, don't need to be updated that often. The problem with offset, the real problem with offset is the consumers have to update offsets pretty much every some seconds. ACLs don't. We could. At the time of this implementation, it was the easiest option anyways, number one. And two, as I said, it doesn't really put any load on it. So we just went with the simplest approach that was available. It could be done. Yeah. So I think the mirror maker story is if you are reading from one secure or unsecure cluster, and then you are writing it down to a secure or unsecure one. You just need to make sure that when you are connecting to the secure side, you are actually authenticating, and you have the right ACL. Whereas on the unsecure side, it doesn't matter. You need to make sure that you are communicating over the port, which is unsecure. So again, mirror maker across these kind of setup. We haven't done any testing, but I would imagine because
I can speak for the LinkedIn. So they actually kind of did the same thing. They have one. So within data center, they are okay with using a non-secure cluster. But if you're going for extra data center, they want to wire encrypt and also provide security. So they run a non-secure consumer and a secure producer from the non-secure source cluster. So they were able to connect to the other. And one other thing is the cross-relim, and we do support that as part of this. So you can have a cross-relim tokens that is being exchanged. That works. So as long as you have it's basically pretty much everything is driven by config right now. So in your producer properties, you set all these parameters, and you're pretty much done at that point.
So if you're doing different rounds, that's not a problem?
Yeah. Yes. Yeah. Yeah. Yes.
SSL for authentication, not with SSL. In that case, how is the Zookeeper story fit into an SSL secure cluster?
Are you looking at the authorization part of it, or?
So what I saw, the Zookeeper is only SSL based authorization and authentication, but I don't have any SSL. I'm just using SSL also for the SSL authentication. So how do you put security around Zookeeper if I don't have that?
so in Zookeeper, I don't know if Zookeeper actually has they have SSL, but I don't know if they have Ssl support over SSL. SSL two-way basically. So I don't know if they have it or not. If they don't, then I think your only option is to make sure that Zookeeper is secured using Ssl.
Yeah, but on the create topic,
Right.
they don't support SSL.
Who doesn't support SSL?
Kafka client.
Kafka
Zookeeper
client won't support it. Yes.
Yeah.
Yes.
So even if I try to do SSL on Zookeeper, the Kafka client won't support SSL. Create topic around it.
So there are two.
So
Go ahead.
Yeah, as a client, you can actually go and create. Anyone can go and create your Zookeeper because it's being unsecured. I mean, that's an unfortunate block that is there if you're using an SSL. What we recommend is use firewall to actually make sure that only Kafka brokers can access it. Given that all the security part is right now in the new consumer API, new producer API, we don't support the old producer and consumer. That means pretty much clients are not dependent on Zookeeper anyway. So you're actually talking to brokers. You can all the channels will be encrypted using SSL. Whereas Zookeeper communication that only happens for the Kafka brokers can be firewalled around that. So if you don't want to use Ssl, that's the only option.
Or you could go with MD5 Digest, which is supported, and you wouldn't need Kerberos for it.
Yeah, there is a. Sorry.
No.
We don't.
It's not right now supported. There is some discussion around creating namespace in Kafka. So once we have that, there'll be a little bit more final grain control that you could, give, or not final grain, but more like this namespace you have access to rather than defining it at a topic level. But for partitions, no. It's just assume that the lowest granularity is topic.
Yeah.
I think that's it. Thank you, everyone.
Thanks.